Hi everyone. I have some information that I want to provide to you for our Unit 3. Many people get confused with many of the directions because of the terminology. It's not something that they are familiar with. So I wanted to go over these things with you to make sure you have an understanding of them. And then we'll move on and take a look at slope and writing an equation to a line, which is very much a part of your Unit 3 objectives. One of our first vocabulary terms that we have is relation. Now, in mathematics, a particular relation that we are referring to is an ordered pair, the XY ordered pair. And I have this indicated over here, and the way that in which the coordinates should be written, always with open and closed parentheses, with the X value being first, a comma, and then the Y value. So you want to make sure that anytime you're asked for a point, that you have all components that represent a point. So a relation is nothing more than a set of ordered pairs. And then our next term that we have here is domain. What is a domain and what is a range of a relation? Well, the domain is nothing more than the set of all the X values. And remember, your X values are the first term in your ordered pair. Your range is a set of all second components in your ordered pair, which is your all Y values, would be referred to as elements of the range. Now, another word that we have in our vocabulary for Unit 3 is a function. What is a function? A function is a relation in which each element of the domain corresponds to exactly one element of the range. And I've provided for you a page number in your text that you might want to take a look at that will review some of these concepts, give you examples as well. I have given an example here of set of ordered, a relation. Here's a relation, the ordered pair 1, 7, 2, 7, 3, 7, 4, 7. So if you're asked to list the elements of the domain, remember the domain is all the components that are X values. So for this case, it would be 1, 2, 3, 4. All right, now if it asks for the range values, all of our range values are the same, and that value is 7. Okay? Now on this next example, if we were to list our elements of the domain, and I'll just put a D for domain and R for range, we have 2, 3, 4, and then we have another 3 here, but we do not need to list it again because we already said that 3 is an element of the domain, so there's no reason for us to list it again. Now the elements of the range are 7, 8, 9, and 10. Now once we have a good understanding of what represents the domain and what represents the range, then we can ask ourselves, well, does either of these relations represent a function? And so what we want to make sure is that the definition is satisfied, which in everyday terminology simply means that no X value is repeated with a different Y value. Now in this first set, or this first relation, we have 1, 2, 3, 4 in our domain. No domain value is repeated. So for this one, I'm just going to write a great big yes, it is a function. Okay, now over here, our domain, 2, 3, 4, 3. So you see the 3 is repeated. And I'm going to put this little machine right here to try to help you to get a better idea. Like if you worked at a manufacturing company or something, and you put a 3 into the machine, and it goes in here and it does all of it, whatever it does. And then out shoots 8. So that would represent this first ordered pair, 3, 8. Well now, if I work for a company and I put that same 3 in there, I'm going to be in big trouble if what shoots out is something other than an 8, right? And so according to this ordered pair, if I put a 3 in, sometimes I get an 8 and sometimes I get a 10. So that is why it's not a function, because you cannot always predict what the outcome will be. Now, make sure you understand that it's the X value that cannot be repeated. like over here in this example, all the y values, the elements in the range, were 7. So 7 was repeated. But now it's okay for the y value to be repeated and it still be a function. That is quite all right. So hopefully that a little example there and reviewing those terms help you to understand what exactly is a function and the other parts of it like domain and range. Now, we have lots of formulas in section or unit 3. So we want to take a look. Just say, for example, if I had numbers like 20 and 850. And then I had another value that's negative 10 and 710. And these are ordered paired with the x being first and the y being second. So if I had to find the slope, I would look at my formula and I understand that it's the difference of my y's, which is here. So I would have 850 minus 710 over the difference of my x's. And since the 850 was first, then I need to put the 20 first in the denominator because they correspond with one another. And I have minus 10. And then I will simplify this and I'll get 850 take away 710 is 140. But here, minus and minus is a plus, so that's a 30. And so my slope, I have a y here, this should be m. This is my slope. M is my terminology for slope. My slope would be this value, and I could round off to the nearest third or fourth decimal. So I would put this in my calculator and see what I have if I divide this out. And I get a numerical value of 4.666, and it just keeps going. So if I had to round off, say I round off to the tenths place value, I would look behind it. And my rounded off answer would be 4 67/100. So that would be my slope. And it's okay to have a decimal. Just make sure you read the directions so you'll know how to round off correctly. Now once I have my slope and I've got 2 points, then I can use what we call the point slope formula. And I can write an equation to a line that has this slope and passes through these points. And so I'm going to pick the first one since everything's positive, but it really doesn't matter which point you select. So I would have, for my point slope formula, y minus my y value, which is 850, equal my slope, which is 4 67/100 times x minus my x value, which in this case is 20. And these formulas are provided for you in your presentations as well as in the textbook. So here, I want to simplify this, and to do so, I have to use the distributive property by taking what's on the outside and multiplying it times each term on the inside. And when I do this, I just want to make sure that I keep up with everything, all signs, that sort of thing. So 4 67/100 times x is simply 4 67/100 x. But 4 67 times 20, negative 20, is negative 133 4/10. So that's a decimal here. Now here is what we're doing. We're showing our work, which is a requirement on some of your assignments for this unit. Now to isolate my y, I need to move this 850 over, and I do that by adding 850 to both sides. So I get y is 4 67/100 x, and then I have that negative 133 4/10 plus 850, and that gives me a value of 716 6/10. So this would be what we call the slope-intercept form of the linear equation. Whereas this is the point slope that we first start with, but we end up with the slope-intercept form of the equation. And because my slope is positive here, a positive value, I know that on the graph, it will rise up from left to right. So I hope this was helpful to you in reviewing over this and one of your main concepts. And I encourage each of you, if you have any questions, just be sure to reach out. I'm here to help you. Just send me an email and I'll answer any question that you have.